Hi guys, welcome back to another video. In this video, we are going to discuss about strong and weak electrolytes, degree of dissociation, the relative strengths of acids and bases, calculation of values like Ka and Kb, and we shall also discuss the law of mass action. So this is going to be a power-packed video loaded with concepts. So I want you all to stay with me throughout the video so that you won't miss on any of these concepts. Hi guys, welcome back to Pharmawise. So friends, let's start the discussion with the question, what are strong and weak electrolytes? So strong electrolytes like strong acids or strong bases are the substances which dissociate completely in their solutions to produce the corresponding ions. For example, acid like HCl when dissolved in water dissociates completely to form H plus and Cl minus ions, and then these H plus ions react with the water in the medium to form H3O plus, that is hydronium ions. So the initial concentration of acid dissolved and the concentration of hydronium ions in the solution will be exactly equal because all the HCl molecules are now dissociated to produce hydronium ions. Okay. Similarly, strong bases are the substances like NaOH who, when dissolved in water, dissociate completely to produce hydroxide ions, and these hydroxide ion concentration will be equal to the initial base concentration dissolved in the solution. So these are strong electrolytes. Let's take some examples of strong acids. The examples are hydrochloric acid, sulfuric acid, nitric acid, then perchloric acid, etc. Okay. And the examples of strong bases include bases like NaOH, KOH, potassium hydroxide, lithium hydroxide, barium hydroxide, calcium hydroxide, etc. So as you now know, the strong electrolytes will dissociate completely to produce the ions. Okay. Now let's come to weak electrolytes. Now weak electrolytes like weak acids or weak bases are the substances which do not completely dissociate in their solutions, but they only dissociate partially. For example, in a solution of 0.1 mole per liter, only about 1% of the acid or base will be dissociated. So the concentration of ions which it is going to produce after dissociation is very less compared to the initial concentration of acid or base. For example, acetic acid CH3COOH is a weak acid. So when it dissociates, it produces CH3COO minus plus H plus, and H plus will again react with the water to form hydronium ions. But here in this case, the hydronium ion concentration will be always less than the concentration of dissolved acid. Now you know why. Similarly, for weak bases, we'll take an example of ammonium hydroxide. They will dissociate to form NH4 plus OH minus, and here also the concentration of OH minus ions will be always less compared to the initial concentration of ammonium hydroxide dissolved. Some other examples for weak acids include formic acid, acetic acid, etc. For weak bases, examples are copper hydroxide, ammonium hydroxide, etc. So I hope this concept of weak and strong electrolytes is understood. Now if you understood, then you must be now clear that weak electrolytes are the ones who are going to dissociate partially. But how many moles they are going to produce after dissociation, that we don't know. For strong electrolytes, we are sure, okay, whatever amount of acid or base we have taken, they all of them have undergone dissociation. But for weak electrolytes, we have to decide how many moles of the acid or bases are undergoing dissociation. So how we will do it? We will do it with the next concept, and it is degree of dissociation. So now we will learn what is a degree of dissociation. So the degree of dissociation referred as alpha is nothing but fraction of total number of moles dissociated at equilibrium to the total number of moles of electrolyte, either acid or base. Means whatever amount of acid we have taken, acid or base, okay, electrolyte, total number of moles of electrolytes, whatever we have taken, okay, out of those total number of moles, how many number of moles actually dissociated to produce the ions at any given temperature at equilibrium. That will be called as degree of dissociation, and it is shown by this symbol alpha. Okay, so degree of dissociation is actually a very good parameter to tell us how many moles of electrolyte are actually dissociating at the equilibrium. Okay, so for a strong electrolyte, how many number of moles you are taking, the number of moles you are taking are getting completely dissociated. For strong electrolytes, your alpha value will be 1. But for the weaker electrolytes, total number of moles you are taking are not getting dissociated, only a fraction of them will get dissociated. For example, if I take 10 moles of any electrolyte and out of it only 1 mole is getting dissociated, then the value of alpha becomes 0.1. Means for weak electrolytes the value of alpha will be less than 1. So alpha value gives us very clear cut indication of the strength of acid or base or electrolyte in general. So this is degree of dissociation. Now we are moving towards the next point, which is the relative strength of acids or bases and how we can determine it with the values like Ka and Kb. So stay tuned. I keep on posting videos loaded with concepts like this one on this channel. So if you are new here, please consider subscribing and also hit the notification bell so that you will stay notified. Now coming to the third point, relative strength of acids and bases. Now how you will actually count the strength of acid or determine the strength of acid. For example, I have a monoprotic acid HA, and when it is dissolved in water, actually it undergoes dissociation to give H3O plus A minus. Now for simplification purpose, if the solution is occurring in dilute medium, the concentration of water is constant, so I am going to remove the H2O part from both the sides and I'll just use this portion as H plus and A minus. Okay, this is one and the same. So when such kind of reaction is in front of you, and I have shown the reversible arrow here and I have told you that the reaction is reversible, the acid is weak electrolyte, and tell me what is the relative strength of this acid, what is the strength of this acid. So you first will ask me, ma'am, what do you mean by strength of acid? So strength of acid means when that acid is in solution, how many H plus ions it is producing. That refers to the strength of acid. So we don't know how many H plus ions this HA acid is producing because it is a weak electrolyte. We have taken that many moles, but all of them are not getting dissociated, so we don't know. So how we can know? So we have to come up with some constant. So the constant we will need here is called as acid dissociation constant, and it is shown by Ka. But how to get that value of Ka? What is the equation for that Ka? For that we need to understand one very important law here. This law was given by Goldberg and Wage in 1867, if I am not wrong. Yes, and this law is very popular and it is called as law of mass action. And what does the law of mass action state is? The rate of chemical reaction is directly proportional to active masses. Now at that time they were using the term active mass, for which we use the term concentration nowadays. So active masses of reacting substances. So who are the reactants for that particular reaction? Their concentration will be directly proportional to the rate of concentration. This was a very famous law given in 1867, and this law is called as law of mass action. So I am quickly going to give you some insights about the law of mass action. We will take an example. for a reaction, reversible reaction which is occurring in a homogeneous medium, A plus B are reacting together to give C plus D. Okay, now in this reaction there are two reactions involved. Because I have drawn a reversible arrow here, A plus B are giving C plus D is a forward reaction, and C plus D are coming back to form A plus B is a backward reaction. So I'll write some equations here, just pay attention. The velocity of forward reaction, the rate of reaction. So the velocity of forward reaction, the rate of reaction will be directly proportional to active masses of reacting substances. Now for forward reaction, who are your reactants? A and B are your reactants. So the concentration of A into the concentration of B will be directly proportional to VF. Now I will remove the proportionality sign by just putting a constant here, and now my equation becomes Vf is equal to K1 into A into B. Similarly, for backward reaction, I'll write the velocity of backward reaction. Now who are the reactants for backward reaction? C and D. So the concentration of C into concentration of D will be proportional to velocity of backward reaction. So I'll also remove the proportionality sign here by putting a constant. So it will come Vb is equal to K2 into concentration of C into concentration of D. Now you know when the reaction reaches equilibrium, when a reversible reaction reaches the equilibrium, the velocity of forward reaction will be equal to velocity of backward reaction. So I can say this is equal to this. So I'll write it here, Ka into A into B will be equal to K2 into C into D. Now I'll just rearrange it to give K1 upon K2 will be equal to C into D upon A into B concentrations. Okay, now both of these are constant, so I can easily write one constant here, and this equation will be K is equal to this equation, and this is constant is equilibrium constant. Now if you are using acid for this reaction, you will write Ka here, acid dissociation constant. If you are taking base here, you will write Kb, base dissociation constant. So depending on which reaction you are referring to, this equilibrium constant or dissociation constant can help you out tremendously. Okay, I hope you understood the law of mass action, and now is the key point of this video, how you are going to use the values of Ka and Kb to determine the relative strengths of acids and bases. Let's discuss in a moment. So now coming back to the equation, Ha gives H plus plus A minus, the reaction is reversible, and as you know, for reversible reactions, if we want to determine the dissociation constant, now this is an acid, I will write Ka here, and I know how to determine the equation because we have just studied the law of mass action, and it states that the dissociation constant will be the ratio of concentrations of resultant products of the reaction to the concentrations of reactants in the reaction. So I have only one reactant here, Ha, and I have two resultant products here. So I'll take a ratio of their concentrations, and that will give me the dissociation constant for that particular acid. So Ka is giving H plus into A minus upon H. Now look at the equation carefully, and you will come to know that how many H plus ions are getting generated is clearly, proportional to the value of Ka. If your value of Ka is high, the number of H plus ions also will be higher, or vice versa. If you are producing higher number of H plus ions, if that acid is producing higher number of H plus ions, the value of Ka will be automatically higher. So here we got the clear-cut indication about the strength of acid. What is strength of acid? How many H plus ions that acid is producing, and how many H plus ions that acid is producing is directly related to the value of Ka. So if you have two acids, acids A and acids B, and if you know that the Ka for this acid is 6 into 10 raised to minus 3 and the Ka for this acid is 8 into 10 raised to minus 3, you clearly know this acid has higher Ka. Higher Ka means this acid is producing higher number of H plus ions. So B is stronger than A. This is what the relative strength of acid is. Okay, you are able to tell that which acid is stronger, which acid is producing more number of H plus ions. So Ka is the clear-cut indication of the strength of acid. Higher the Ka, higher, greater is the strength of acid. Okay, lower the Ka, lower is the strength of acid. The same explanation applies to base. For example, let me take an example of a base like BOH, and it dissociates to produce B plus and OH minus. So it is producing OH minus ions, means hydroxide ions. It is a base. It is a reversible reaction. So the base is a weak electrolyte. So I will write the dissociation constant for this base as Kb, and I'll write the equation like concentration of B plus into concentration of OH minus upon concentration of BOH. Now see here, like the concentration of H plus was related to Ka, here the concentration of OH minus is related to the value Kb. So higher the number of OH minus ions produced by the base, higher will be your Kb value. Are you getting it? Lower the concentration of OH minus, lower will be your Kb value. So Kb value is giving you the clear-cut indication of strength of base. Higher the Kb value, greater is the strength of base, and vice versa. Are you getting it? This is how you determine the relative strength of acids and bases. Okay, theoretically you got it. I am going to give you an equation which you will use instantaneously for determining the relative strength of acids and bases, and I'm going to write the equation here. Okay, so just a ready-made equation. Strength of acid 1 upon strength of acid 2, any acid you can take, is equal to under root Ka1 upon Ka2. You have to know the acid dissociation constant for this acid, acid dissociation constant for this acid. If you know the values, you just put the values in this equation and you will get the relative strength of acids. Similarly, strength of base A1 upon strength of base 2 is equal to under root Kb1 by Kb2. It is as simple as that. You just need to know the values of dissociation constants for your particular electrolyte, and you can have the relative strengths of acids and bases. See, you are having the ready-made equation. I am giving you the ready-made equation. So now you have to like the video and share this video with your friends. Really, please. And if you're not subscribed, please go and subscribe. You just have to hit that red button and turn on the notification bell so that you will be notified as soon as I post such informative and educational videos. They are going to help you, and I assure you that I'll give you the quality content all the time. Okay, so yes, now we'll just recap whatever we have studied. The first point we studied was the strong electrolytes, weak electrolytes. Strong electrolytes are the ones who dissociate completely to produce the ions. Weaker ones, they do not dissociate completely, they dissociate partially. Then we studied what is degree of dissociation. It is the extent to which the electrolyte dissociates, and given by alpha. The equation is number of moles dissociated to total number of moles of electrolyte. Then we discussed the law of mass action. Means the velocity or the rate of reaction is directly proportional to the active masses of reacting substances. And then we have discussed the relative strengths of acids and bases. What are the Ka and Kb values, what is the acid dissociation constant, what is the base dissociation constant, and how you can use those values to your benefit to determine the relative strengths of acids and bases. I hope you are getting whatever I am telling you, and if you have any doubt, go in the comment section and ask me. I'll be more than happy to help you out. And if you have some queries, some doubts, you want me to cover some topics, go in the comment section and tell me your query. I'll try my best to make a video on that query as soon as possible. Keep watching Pharmawise and subscribe to the channel for more such videos. I'll see you in the next one. Till then, take care. Bye bye.